Hello everyone. In today's video, we'll be talking about Physics 253, Week 1, Practice Problem number 22.36. In this problem, we are asked to find the magnitude of the charge of two spheres that are equally charged and placed next to each other, and when they're released, they begin accelerating. So, to start off this problem, we can go ahead and draw a little picture. So, since these spheres are equally charged, we know that they're obviously going to have the same charge. So we could depict this in two ways. So we could say that it's either going to be a negative charge for both of the spheres, or it's going to be two positives like I've drawn here. In another scenario, you could have one be a positive charge and one be a negative charge. But since these spheres are, as stated, equally charged, I've decided to draw them as two of the same charge. So we have weight, acceleration, and the distance at which they're placed. And I think it's important to go ahead and note that we're going to be relating the forces in this case, because through force we will be able to solve for the charge. And so what we can do, we can say, well, the force of the electric field is equal to the charge times the electric field, and the strength of the electric field. And then we can also say that due to Newton's second law, force equals mass times acceleration. From here, we can set these equal to each other. And we can then solve for Q, our charge, and just kind of rearrange. For our E here, our electric field, we can go ahead and substitute this equation that uses the Coulomb constant and the radius, as well as the charge. And here's our Coulomb constant here, to go ahead and solve. So what I've done here is I'm just kind of solving algebraically for our expression, and I end up getting this, and this is going to be the magnitude. So normally we would have a plus and minus at this stage, but since it's the magnitude, we can just go ahead and say that it's going to be the absolute value. So after plugging in our values here, this is going to be our radius in meters, and this is going to be our weight of the spheres. Here's our acceleration, and here's our Coulomb constant. And when we plug all of this in, we get that the magnitude of the charge on each sphere is going to be about, after rounding, 62 nanocoulombs. Thank you very much for watching, and I hope you found this video helpful.